Honeybee Communication, presented by Haley Riddick, Travis Rames, Isaac Luna, and Stephen Martinez. Honeybees communicate in a variety of different ways. This is known as a multimodal communication system. Three types of communication include chemical, which uses the spread of specific pheromones to elicit certain behavior throughout the hive; visual communication, which includes a variety of dances as well as defensive posturing; and auditorial communication, which consists of piping and tooting. Put simply, pheromones are a chemical used in communication among members of the same species. Pheromone reception is affected by a variety of factors. Most pheromones have either a primer effect or a releaser effect, and in some cases, certain pheromones will have both. Pheromones with a primer effect trigger the endocrine system and cause honeybees to create or stop creating certain hormones. On the other hand, the releaser effect pheromone triggers an instinctual behavioral response. Volatility of a chemical determines how a pheromone is spread based on its solubility in air. Highly volatile pheromones spread long distances like a strong scent. Pheromones like QMP and brood pheromones are non-volatile and spread through contact. Pheromones also have two different types of signal intensities that affect behavior: graded and discrete. The intensity of graded signals gives different information and determines how a honeybee reacts. However, discrete signals call for the same behavior and works like an on and off switch.
Chemical signaling bee response. Queen mandibular pheromone signals many responses. The retinue response in worker bees, which is the gathering of worker bees around the queen bee to take care of her many needs such as food, cleaning, and removal of waste. Another response is clustering, which happens when the hive swarms into one location and the bees are all clustered together in a one large bivouac. Also, queen mandibular pheromone is responsible for reduced ovary development in worker bees, and also influences the activities done by workers such as comb building, foraging, and storing of food. Lack of queen mandibular pheromone results in queen rearing cells made by the workers, and also workers will also try to lay their own unfertilized eggs. Brood pheromone is also responsible for reduced ovary development in worker bees, along with encouragement of foraging. Alarm pheromone, Koschevnikov and the sting gland are responsible for the production of isopentyl acetate, which is the chemical that is released when a bee stings another organism that is not a honeybee. 2-heptatone is an alarm pheromone released by the worker bees from the worker bee's mandibular gland. The DeForest gland is a gland that the queen that's used, and when the queen lays eggs, a pheromone is put onto those eggs, and the workers can tell which eggs were laid by the queen, and if the egg was not laid by the queen, the bees will remove that egg. The Arnhart gland is a gland located on the feet of the honeybees that is like a scent trail of honeybees. The Nazanov glands is a chemical secreted from the tergites of the worker bees, and it is a signal saying that this area is safe and good. It is used when scout bees find a new site. They will place the scent from the pheromone from the Nazanov gland on that new site, and it will help the other bees to find it.
Visual communication in honeybees. Visual communication is one of the multimodal forms of communication and is a key method for honeybees to signal one another or other organisms. The only downside to this type of communication is that it cannot be seen in the dark. Typically, it is used for defense. An example would be the forward projection of their forelegs to appear large and threatening to their enemy. This body gesture gives the enemy a visual display to warn them that they shouldn't come any near. Another visual defense mechanism is charging. Honeybees will dart towards the enemy like a bull with its horn projected forward. Most of the time, this will be done by soldier bees. Of course, honeybees are notorious for their dances. These dances communicate to other foragers, recruiters, and workers. The waggle dance is the most important because it is the main method in showing foragers where food sources are at. The angle of the waggle dance indicates direction, the duration of the waggle dance indicates distance, and the value of the sight is indicated by the vigor of the dance and the amount of times that it was repeated. For food that is nearby, honeybees will utilize the round dance. The breaking dance is a type of communication in which bees run through the hive to initiate a swarm. The shaking dance is a side-to-side body movement where the bee grabs another bee to dance with. It's like one saying, "Come on, we gotta go," to another. The dorsal ventral abdominal vibrating dance, the DVAV, is used to encourage bees/queen to leave the hive. There may be other visuals incorporated into a bee's form of communication, but this is what scientists are aware of now. Honeybees are definitely intriguing organisms that are unique and smart.
Bee communication is majorly chemical and physical. However, there are circumstances where bees will vocalize in order to communicate. The most popular auditory signal is queen piping, or otherwise called tooting. This occurs when a newly emerged virgin queen is trying to establish her dominance in a hive. She will go around tooting for 1, to make the rest of the colony know of her presence, and 2, to let the unemerged queens to stop their attempt from breaking into their cells. Tooting starts with long syllables lasting about 1 second, and then a decrease in longevity. The unemerged, or sometimes other newly emerged queens, will begin to quack back as a way for the other queen to find them, which is a series of short syllables lasting 0.1 seconds. However, this isn't an invitation for a picnic. The queen is trying to get rid of her competition, so when she arrives at the other cells, she tries to kill them by stabbing into their cell with her stinger. Queens can start piping when they are 1 to 2 days old, and interestingly, bees register the noise through comb vibration and not through sound. Another but less known calling is when scout bees tell the rest of the hive it's time to go. Usually this occurs in the event of swarming, and this happens by scout bees piping around the colony, letting the colony know it's time to warm up and get ready to fly.